MOSFET. And this is the physical design of our controlling circuit. This is the RS232, and these are the parallel N MOSFETs, and this goes to the vibrator and so on. And our advantage for this system is it's simple, it's inexpensive, and from experience, it's very reliable. And it can be precisely controlled without the advantage we have. For the image processing process, for the imaging processing system, Priyanka will talk to you about it.
For our image processing part, we approached 3 methods. One by calculation by area, which the advantage was fast and simple algorithm, but it did not allow us to have a visual result, and the inaccuracy of the result increased as the number of pills increased. Then we approached the half transform method, which was very accurate, and it allowed us to have a visual display, but it was extremely slow because of the high number of iterations, and when we tested for around more than 10 fields, the program would crash. And also because of the complex algorithm for elliptical fields. The current method we are using is morphological operation. The morphological operation proved to be fast, accurate, allowed us to have a visual display, and the algorithm was very simple compared to the half transform. The only drawback was we have to set a certain threshold for pills of different sizes. This is how I'm going to explain how the image processing part works. First, we take a picture of one pill, and then we change the image to a grayscale. Then we edge detect it using Canny algorithm. Canny algorithm allows us to do edge detection, removing all the edges except for the desired ones, leaving the desired ones. Then we use the region props command to calculate the eccentricity of the 2 shapes. If it's a circle pill, it will range from 0 to 0.5, and if it's an ellipse, it will go from 0.995 to 1. Depending on the value of the eccentricity, it calls a particular function. Then we take the image of the pills from the fixed height. Then we crop the background to remove the unwanted background. Then we change the image to grayscale using the RGB to gray command. Then we set the image threshold to 127, which means it sets the background to 1 and images all the objects in the images to white and all the backgrounds to black. And then we use commands provided by MATLAB, erosion, and which allows the circular pills to erode from the boundary towards the center in a circular way, and the elliptical pills erode from the boundary towards the center in a squarish way. This is where we set the threshold. For bigger pills, through many tests, we found the threshold was 6. For smaller pills, the threshold was 3. The reason why we use erosion is to detach any initially attached pills. Then we use the shrink command to shrink the objects in the image to a single pixel. This way, for every object in the image, we have a single pixel. Then we draw a circles around the single pixel of the desired radius. Here we will use the radius of 1 pixel. And then we use a counting algorithm to count the number of pills. And then, depending on the desired number of counts, we remove the ones that we do not want and only display the number of pills that we actually want to display. And Jesus will explain us the test criteria results.
Yeah. Due to the time limitations, we're just going to skip right to the demo video.
Just too fast.
Yeah, a couple of minutes. Let's see how it's done. Well, when we first started with this project, we set out to meet certain criteria. Specifically, we had speed, capacity, adaptability, accuracy, and ease of use. The system can count up to 60 pills per minute. You can put up to 120 pills per time on the tray. You can count 3 different shapes of pill: triangular, circular, and elliptical. It's fairly accurate, about 90% of the time. And it's very easy to use thanks to the GUI. Here's the graphical experimentation that we did, showing you how accurate the system is. The total cost of our project came up to, with labor included, to $9,278. Thank you to all these. Sorry. Thank you to all these people that helped us with the project. Do the demo. Well, here's the method. Here's where we specify the number of pills that we want out of the tray. And we have to hit the start button for the process to start. Here, there's a prompt that tells the user when to put a pill and when to put the rest of the pills in there. First, you have to do a reference pill to tell the image processing what the shape is, how big it is, and for the spell. And then you roll all the other pills that you want to count. And you see the spell in the file. Then, as you can see, all the pills are on top of each other. And that's where the solenoids and my variator motors come in. They shake the tray and they spread the pills out. Then the results go to the GUI and I'll display to the user. This method within the processing, and the results should come up shortly. So the results, the weight, as you can see, the weight count and the visual count match. And it also gives you an excess number of pills on the tray. And this is how the projector tells the user which pills that he wants to remove from the tray, and he actually put on his prescription. All he has to do is just push him to the side with the roll. And that's it.
Those dots.
How did the dots get on the bills?
There's a projector on top of the whole system. I saw in one of the first images. And there's one of the easy slide outs on the side. You can collect the pills and put them on the top. That's it.